Anna, Maddie and Grace try to go out to lunch every Friday. However, on any given Friday, one or more of the girls may not be able to make it to lunch. The probability that Anna cannot make it to lunch is 0.2, that Maddie cannot make it to lunch is 0.4, and that Grace cannot make it to lunch is 0.15. If these are all independent events, determine the probability distribution for the discrete random variable x, which measures how many of the girls can make it to lunch. So what we can do is we can answer this question by looking at the four possible cases, those being that none of them can make it to lunch, exactly one of them can make it to lunch, exactly two of them can make it to lunch, and that all of them can make it to lunch. Just before I reveal the solution to this, what you can do to calculate these yourselves is to multiply each of the probabilities together because they're independent to get the intersections. So if we have a look, the probability that none of them can make it to lunch is simply the probability that Anna can't make it times the probability that Maddie can't make it times the probability that Grace can't make it. So when we do that, we get 0.012 as the probability that none of them can make it out to lunch. If we continue this, we get that there is a 0.134 probability that exactly one of the girls can attend, a 0.446 probability that two can attend, and a 0.408 probability that all three can attend. So we've put this in a table here, and this is the distribution X, which measures how many girls can attend the lunch. Part B asks that the girls decide they will only go out for lunch if at least two of them are available. Find the probability that the girls will go out to lunch on any given Friday. This is essentially saying that the probability that they go to lunch is equal to the probability of X being greater than or equal to 2, which is the same as the probability that X equals 2 plus the probability that X equals 3, which is found by adding these two numbers together. So that equals 0.446 plus 0.408. And if you add those together, you get 0.854, which is the probability that the girls will go out to lunch. Part C then says, what is the probability that all three girls went out for lunch, given that the group attended lunch? Give your answer correct to 4 decimal places. So this question is asking for the probability that X equals 3, given that X is greater than or equal to 2. The conditional probability is found by finding the intersection of those two, so X equals 3 intersecting X is greater than or equal to 2, and dividing it by the condition, which is the probability that X is greater than or equal to 2. So if we do that, the intersection is in fact just X equals 3 divided by the probability that X is greater than or equal to 2. So if we put in those figures, we know that X equals 3 is 0.408, and that the probability that X is greater than or equal to 2 we found on the previous slide, which is 0.854. And if we evaluate that, we find that this is 0.4778, correct 4 decimal places, which is the probability that all three girls went out to lunch, given that the group attended lunch.